Welcome to the sixth video of our checkpoint lab series. During this video, we will search the connection table for a particular connection. Also, we will generate some test traffic through the firewall cluster, and we will see how connection table synchronized between two cluster members. We will also try deleting the connection from connection table and do some experiments to see what happens with the traffic when the firewall doesn't have the connection in the connection table anymore. The best way to understand how firewall handles connections in connection table is to do some experiments. We will start with login to our gateway number 1. And in the gateway number 1, we can check what's inside the connection table. For this, we can use LW tab, st connections. And it shows all the connections we have in the connection table. This table is not very clear and it's hard to understand what's going on. To simplify, we can instead use the other utility. It is fwctl conntab. Conntab was introduced in R81 and it shows the same information in most straightforward way. In the connection table, by default, all the connections are in hex format, and crontab already converts everything in decimal. To convert the output of connection table to decimal format, we can use fwtab -t connections -f. This output at least shows us IP addresses and source destination port in decimal format, and it is a little bit easier to understand. We can also use fwctl conntab to filter out connections and display only connections that we want to see. For this, we need additional flags, for example, -source IP, and let's try to find all the connections from smart management server. And also, as a destination filter, we will set up firewall number 1, our gateway number 1, 6.8.43.2, and this shows us all the connections between Smart Manager and gateway number 1. If we want to be even more specific, we can add -source port and set the source port equal to one of the connections, like this. At this point, you may ask, okay, now we can search connections in the connection table. We see that connection table has all the connection that firewall can pass through. How it is connected with ClusterXL. ClusterXL is the clustering protocol, and the reason why we even need a clustering protocol and we cannot stick with only using, for example, VRP or HSRP is because neither VRP nor HSRP provides a connection state synchronization between systems where it is configured. ClusterXL and basically any other clustering protocol has the main goal not only provide a redundancy but also provide redundancy with a stateful inspection of the ongoing connections. ClusterXL works well by synchronizing connection tables between firewalls in the same cluster. Let's now see how it is happening in real time. To demonstrate how connection synchronization works in real time, we will need to open another SSH session to gateway number 2. And let's put it side by side like this and make clear to have the clear screen by start of our testing. Okay, good. Now we will use fwctl conntab to show the connections we really want to see. And for testing, we will use connection between our administrative laptop and smart management server going through the firewall. 16.1.100. And we will use SSH connection. That's why we will specify destination port equal 22. And we want to continuously update the status of this search. For this, we will use command watch -n every second -d, and that's the command that we are using. Exactly the same command I will use on the gateway number 2. Here and here. Right now we have no connections, but if we want to test and we want to see something, let's initiate a SSH session from admin laptop to SMS. We go admin, VPN123, and we see that almost immediately both cluster members have the same connection in the connection entry. We see that the timeout timer updates every second. We see source, destination, we see the source port, and we see the connection state that TCP is established. So this is very good. Now what we can do, we can basically disconnect this SSH session, just exit, and we see that it is source fin state on both cluster members, and then it disappears. Now we don't have the same connection on any of our firewalls. Let's interrupt the command. Now we will try to reestablish the SSH session, and then we will manually delete the connection from the connection table. To do so, first let's establish again the connection to SMS. Now we should have the connection. fwctl conntab minus source IP equal 192.168.43.1 and destination IP equal 172.16.1.100 and destination port equal 22. We have the connection here, and we have the connection here as well. Very good. Now we can try and delete the connection. The easiest way to do so on RT1.10, again with the conntab. For the command, we need just to add -x, and here we will again start watching the connection table. We have a TCP established. We have TCP timeout counter decrementing. Then we will delete the connection on the primary cluster member. We confirm that yes, and the connection disappears on the secondary cluster member. No longer we can use this SSH session because it is interrupted. No more connection on the firewall. You may also ask, we deleted the connection on the primary cluster member and then it was cleaned up on the secondary cluster member. But we are in the active passive. If we do cphaprob state, we see that one firewall is active, the other one is standby. You can do the same on the gateway number 2, cphaprob state. The local one is standby, the other one is active. What would happen if we delete the connection on the secondary firewall but not on the primary firewall? You may want, let's say, to delete some connection on secondary in case if it was primary before, then something bad happened with the traffic, and you think, oh, maybe that's a stale connection on this firewall, so let me first fail over, and then I will delete this stale connection on my now standby firewall because I have the other firewall active. Let's try to do exactly this scenario. We will have again our testing connection to SMS in VPN. Let's open our connection to SMS. Very good. Connection is working. Let's double check what we have in connection tab table. We have the connection on active firewall. We have the connection on standby firewall. We have the SSH working fine. All good. Now let's delete this connection on secondary, and we will watch the connection on primary. Like this. Okay. Enter and confirm. And next second connection disappears from the primary firewall as well. Basically, this means that even if firewall is a standby, and if we manually delete the connection from connection table from standby firewall, it will make an impact on active firewall as well. Generally, that's a bad idea to try to clean up connection table on secondary firewall, thinking that nothing will happen to the primary, because general assumption is that connection synchronization works only from active to standby. But in ClusterXL, connection synchronization works both ways. That's why if you, for some reason, decide to clean all the connections from secondary firewall, I wouldn't recommend doing that, because basically it will kill all the connection on primary firewall, and all the applications running through the firewall will have to reestablish TCP sessions. Very bad idea. Instead, I would rather recommend just to reboot secondary firewall. Let's imagine still that you cannot, absolutely cannot reboot any firewalls right now, but you desperately need to clean up a connection from secondary firewall to resync the connections, for example, or for some other reason. There is a way to do that. To understand how to do that, we should go to very specific security knowledge article on Checkpoint, and this security knowledge article from the glance that is not actually related to deleting and cleaning up the connections, but it has very interesting instruction about how to restart synchronization between two cluster members in ClusterXL. This helps us to set up another testing. For the test, we will repeat previous scenario, but with one exception. We will stop the sync between two cluster members first, and then we will clean up the connection table on the secondary firewall, and then we will restart the sync. And we will see what happens. For the testing, we need to reopen connection to SMS via Ethernet 1. Then let's confirm the connection. wctl conntab minus source IP equal 192.168.43.1 minus destination IP equal 172.16.1.100. Okay, we have the connection on primary. We have the same connection on secondary. Now it is time for the experiments. First, we go and copy paste the command to stop the sync. And we see that synchronization is off. We can check it with a cphaprob sync stat. Shows that sync status is off, manually disabled sync. And cphaprob state here shows that the other cluster member is down, because we cannot do any synchronization right now. We didn't use ClusterXL admin down command, we just stopped the synchronization. Now let's watch the connection with the watch command. Let's put watch -n every second -d for the command that we already see on the screen. That's the connection. Now we will delete the connection from connection table with a -x, and we confirm that yes. And we have this connection now deleted. If we double check, there should be no connections found. No connections. After that, we can restart the synchronization again with the sync start. Now we can check it with cphaprob sync stat command. Sync status is okay. Connection on the primary is still there. Do we have connection on the secondary? And we have connection on the secondary as well, because it was synced again after we cleaned the connection on the secondary cluster member. If we check cphaprob state, we see again that the primary firewall is active, the secondary firewall is standby. When we disabled the synchronization, we generated an additional log message in var log messages file. We can try to check it. We can do cut var log messages for grep FULLSYNC. And the most recent message is standby to down, reason FULLSYNC pnode manually disabled sync. Means that someone actually issued the command to disable the synchronization. Let's go back to the other way how to see connection table. We don't need the gateway number 2 anymore. Let's close it. And let's do fw tab -t connections -s. This command shows us how many connections we have right now in the connection table, and also shows how many connections we had before. Also, we have a table ID. Actually, we can use a table ID instead of a name. Just put 18158, and it will show us the same information. I'm more comfortable with the connections. We don't have too many connections, we have just 5, so we can display all the connections without any filters. But we see that there are actually much more data than just for 5 connections. And the reason for this is that for each connection we have symbolic links. To understand what is the symbolic link, we should go to the other SK, that's SK 65133. This is a great SK. I highly recommend to read through it. It has a lot of information, and all this information is about connection table format. For the symbolic links, we need to scroll a little bit down, and it tells us that for every connection in connection table, gateway automatically generates 4 symbolic links like this, which represents the potential traffic flow from client to server and from server to client. In our output, we also see the symbolic links. For example, this is the symbolic links, and also this is the symbolic links. Let's try to search something in the connection table. To search something in the connection table, what we need to translate decimal IP addresses in hex format. And to do so, we need some online tool. I would recommend using the tool like online hex tool, like this. And here I already entered the IP addresses for admin laptop and smart management server. We can use these values to search the connection table. Let's copy paste like this. And now we can search connection table using the values on the screen. We can just use, for example, grep and put the IP address of the management server. No, actually it is the IP address of the admin laptop. And we see that there is a connection of the admin laptop. It goes to this destination. Basically, that's the direction of the connection, source IP source port, destination IP destination port, and protocol. That's all we need to find the connection in the connection table. Having the source, let's check what is the destination. To check the destination IP very easy. We can just ping using 0x and then paste the number, and we see that this is our firewall 33.1. Let's recreate our previous testing when we generated a connection through the security gateway and then we deleted the connection with the fwctl conntab. This time we will use just fwtab command to find out how to delete connections with fwtab. You will need another SK, and here it is. It's how to manually delete an entry from connection table. For this, first we need to find the connection entry, and then we need to use -x, -e, and then we need to copy paste 1, 2, 3, 4, 5, and 6 values from the connection table, which represents direction, source IP, source port, destination IP, destination port, and protocol. Let's try to do exactly this. Opening SSH session to SMS. Now we have the connection. Now we need to search for this connection. We will grab the IP address of SMS. And we have quite some number of lines here. What we have source IP, source port, destination IP, destination port. Let's double check this is the source IP of the admin laptop. We do ping 0x paste. Yes, indeed, that's the source IP of admin laptop. This is SSH and this is the protocol. Let's go ahead and copy paste the command fwtab -t connections -x -e, paste, and then we copy 6 values, 1, 2, 3, 4, 5, and 6 values here. Double check the formatting. We don't have spaces between the commas. Okay, let's do exactly like it is in the SK. Let's delete the spaces. And delete. Now it is saying that this entry was deleted from connections. What we have with our session, now SSH doesn't work anymore. We can do another wonderful command of wctl z debug plus drop and then grep 192.168.43.1, which will tell us the reason why it is dropped. And we see that the packet from our admin laptop going to SMS with port 22 was dropped by first packet state check. Reason first packet is not seen. This is the value debug 0, just to ensure that we disable the debug. This is the value of stateful inspection on the firewall, because we do have a rule to allow traffic from admin laptop to SMS by port 22. Still, the traffic is dropped because firewall not only checks the access list itself, it also checks the connection state. And if the connection is not present in connection table, firewall awaits only a seen packet. If the packet is not seen, it will drop it. Also, you may be wondering how exactly the synchronization of connections works between two cluster members. And the synchronization works using the checkpoint clustering protocol, CCP. This protocol sends a lot of packets between cluster members by the synchronization link. And this traffic starting from R81 is encrypted by default. So we can do TCP dump -NI. Ethernet 2 is our sync interface. And here we see that there is a lot of packets going between sync IP addresses of two cluster members by port 8116. If we do a TCP dump to a file, for example, -w and then ClusterXL pcap, and allow it to run for some time. We will capture this traffic to a file. Right now we captured a little bit less than 400 packets. Now we can download it from firewall. To download it from firewall, we will use WinSCP 192.168.43.2, and we continue. Okay, I will replace the previous version, and here we have the file. Yes, we can try to open it, and we will not see anything particularly interesting because all the data is encrypted by TCP. Before the encryption was possible, it was highly recommended to run the sync only on the private link between two cluster members. Now the traffic is secure, and we can send it not only directly between cluster members, but through some other networks, and we can be sure that it will not be intercepted and decrypted, and nobody will know anything about our connections in connection table. Maintaining the connection state is not the only value for the stateful inspection on the firewall. Of course, it is good to catch the SYN flag is not correct during the connection establishment or something else. In addition to this, checkpoint firewalls has so-called core protections in IPS. In threat prevention policy, we have IPS protections, and we can filter by core protections. They have a little bit of a firewall sign, means that these protections are installed and running on the firewall policy even when the IPS plate is not active on the firewall. Basically, these protections are always running. And there are 39 protections by default. In addition to these protections, which you can check in Smart Console anytime, firewalls are checking some sanity checks on incoming packets. For example, it will not allow any SYN packet with a non-zero length or reset packet with a non-zero length, and so on. So stateful inspection provides much more security than it may appear from the first sight. This is the end of our 6th video. In the description, I will provide references for secure note articles about checkpoint cluster protocol, and also about connection table format and procedures how to find and delete a connection from the connection table.